Good morning. In today's session, let's deal with errors. We'll see how Python will handle the errors. We have come across different types of errors like compilation error, logical error, and runtime error. If we make any mistakes in spelling, or we have missed out writing colon in if statement or for loop, then it is called syntax error. This happens in the compilation, during compilation time. Now, if we do mistake in logic of the program, Python will not raise any sort of error, but may not give a proper output. Now, the other type of error is runtime error. Now, when the user gives a wrong input, the execution stops abruptly. So this is called runtime error. Yeah, now let us see this example where we are going to divide a number. We are printing it and we are just at the end we are saying hello Cambrians. Now let me run this program. Yeah, I'll just say give a number. Of course, I got some perfect answer. Now, next time when I say, I'm just going to say 0. So what is that I'm going to get? I'm getting some error. What is that error? 0 division error I'm getting. This is a mistake from the user end. And this is very small program. Assume that there is a millions of transactions happening on the net. And suddenly because of users' mistakes, like what we did now, the software stops abruptly and there is a huge loss, isn't it? So then how to handle such situations? Even if you get such errors, software or execution should not stop abruptly. Instead, it should prompt the user with a proper message, right? Now, what will the user come to know? What is this 0 division error? What is going to do with this, right? This is first thing. And second thing is, if you see print hello Cambrians, it is not printed after this. If you find line number 3, there is an error. That means 0, 1, 2, this line number, c is equal to 10 by x. At this point, there is an error. Immediate after that, it is so evident that it is not printed c anyway, and hello Cambrians also, it is not printed. So abruptly, it is stopped. So this should not happen. So if we want to solve this problem, we need to use a special block. So that is try block. Whichever statement may prone to error. Now in this case, c is equal to 10 by x might have some error. We can't predict. User might commit an error or he may not, right? So put that statement into try block. Now what I'm going to do is I'll put this in try block. Okay. If user does not make any mistake, fine. It is going to execute properly and even it will print the result. Suppose if user makes a mistake, then you are going to put that in a except and you will give a proper message to the user. What you will give? You will say try again. You cannot divide by 0. This is the message will be given. Okay. Now hello Cambrians. Now let me try and execute the program. Yeah. If you see here, enter the 0. Try again, you cannot divide by 0. This message is been given to the user. Now this is a perfect program. And also if you see here, it is not stopped abruptly. Even hello Cambrians is also printed. So I think this is clear with try and except block in Python. Now let us see what is this short circuit evaluation. Let me take this example. For any conditional statements, we use Boolean expression, right? So let us look at this. Now assume that T and T equal to T. This T is some Boolean expression, right? Now when we say true and true, the result is true, right? True and false, the result is false. When you consider these two statements, what is happening here? We have to evaluate both the expressions to get the result, right? So for time being, let me not discuss about this. Now let me see here. In this expression, false and true makes false. Now in this statement, first part is false and result is also false, right? So there is no point in looking for the second part of the expression even if it is true, right? Because we already know what is the result. It is false. This is called short circuit evaluation. Even in this expression also, if you see, first expression is false. I don't mind whether it is true or false, but the result is false, isn't it? So this sort of evaluation is called short circuit evaluation. Now let me take with an example. So I'll be explaining with an example. If you see here, x is equal to 6 and y is equal to 2. Now, when I enter this, definitely I'll be getting true because x is greater than 6 is greater than 2. And when I divide 6 by 2, it is of course greater than 2. So both are true. So you are getting the result as true. Now, let me say x is equal to 1 and y equal to 0. Now when I say enter, what is happening here? False. X greater than or equal to 2. Here itself, in the first statement itself, expression, x is 1. 1 is not greater than 2, so it is false. So you are returning false. It is not going for the second part of the expression at all, right? Now, let me take one more example. X is equal to 6 and y equal to 0. Now, again, I'll take this. Now, what is happening here? When I say enter, we are getting a runtime error. This is the runtime error. Because see here, x greater than or equal to 2 is true because x is 6 here. And x divided by y is, because we are dividing it by 0, we are getting a runtime error, right? See, in this second case, we are not getting. In this particular case, we are not getting error because first time itself it is false. The first expression itself is false. Now, where does this short circuit comes into picture, right? So this is one more example I'll give. Now x is equal to 1 and y equal to 0. Let me take this example. X equal to 1 and y equal to 0. Okay. Now I'll say, I'll consider this statement. I'm going to consider this statement. Now, if you see here, x is greater than or equal to 2. 1 is greater than or equal to 2. No, it is false. So immediately it will not execute y not equal to 0 nor x divided by y greater than or equal to 2. This is called actually short circuit evaluation. There is no point in evaluating because first expression itself is false, right? Now, let me take one more example. X equal to 6 and y equal to 0. 6 is greater than or equal to 2. It is true. And y not equal to 0. It is false. So it doesn't go to this evaluation at all. And it will return false. Now, if you observe here in this statement, y not equal to 0 acts as guard condition because it is avoiding this runtime error because y is 0, isn't it? So suppose if you put this statement in the second expression, then you would have got the runtime error. But here what is happening? You are avoiding the runtime error and you are putting the condition. This condition is called guard condition. Hope these examples have given you clear picture of short circuit evaluation and catching exceptions using try and except. Okay, thank you.